Hey guys, as part of the road subgrade and pavement engineering class, today I'm continuing chapter 5 for asphalt pavement design. And we are at part 3, design parameters. Basically, we will discuss the material properties necessary for layer thickness design. In detail, we will cover materials including subgrade soil, graduate materials, hydraulic bond materials, and asphalt materials. For subgrade soil, if the resin modulus of subgrade cannot meet the specification requirements, different fill materials can be used, or a graduate material, inorganic bond material can be introduced to improve the subgrade. You can also treat the soil with lime or cement to increase its strength. Modulus of subgrade soil is the resin modulus and triaxial compressive dynamic loading and optimum moisture condition with maximum dry density. It was corrected with coefficient for moisture adjustment and a coefficient for dry, moist, and free soil adjustment. During the test, it was loaded with a half-sign load. Based on the test data, resin modulus can be calculated using this equation. Sigma 0 is the axial compressive stress, and epsilon 0 is the recoverable axial strain. For graduate materials, there's a requirement on the CBR value for aggregates used in base and sub-base layer. For instance, the CBR value for graded crushed stone has to be no less than 200 for base layer of expressway and Class 1 highway. Other detailed requirements can be referred to the specification. Besides the CBR value requirements, there's also a nominal maximum aggregate size requirement. For instance, the nominal maximum aggregate size for base layer graduate materials has to be no larger than 26.5 mm. To ensure the drainage capability, the percent passing 0.075 mm sieve for graded crushed stone or graded gravel should be less than 5%. Otherwise, you can replace part of the fine-grained particle with natural sand. Modulus of graduate material is the resin modulus and triaxial compressive dynamic loading. The dry density of the laboratory specimen should be the same as the dry density as in the field. The load applied was a half-sign load. Based on the test data, the resin modulus can be calculated using this equation. For hydraulic bond materials, like cement stabilized materials, there's the nominal maximum aggregate size requirement on aggregates. For instance, the nominal maximum aggregate size has to be less than 31.5 mm for aggregates for base layer for expressway and Class 1 highway. The cement content has to be between 3% and 6% for cement stabilized aggregates to control the shrinkage cracking. The cement stabilized aggregates should be designed based on the 7 days unconfined compressive strength. For cement stabilized materials, the elastic modulus is used in the design. It was obtained from axial compressive loading and monotonic loading. An adjustment factor of 0.5 should be used for the structural calculation. Based on the test data, elastic modulus can be calculated using this equation. For asphalt materials, binders should be selected based on the highway class, climatic conditions, traffic level, layer position, and construction conditions. Modified binders and additives should be used for special locations, like sections with extremely heavy traffic, very heavy traffic, sections with harsh climatic conditions, and sections with steep slopes. Asphalt with high viscosity or crime rubber modified asphalt is suggested to be used for open graded asphalt mixture. In terms of aggregate size, nominal maximum aggregate size for upper surface layer has to be less than 16 mm. For middle surface layer and lower surface layer, it has to be larger than 16 mm. For asphalt stabilized base layer, nominal maximum aggregate size has to be larger than 26.5 mm. In terms of low temperature cracking, the pavement low temperature design temperature is equal to the average minimum temperature of the past consecutive 10 years. For binders, low cracking resistance was controlled through BBR testing. For mixtures, the low cracking resistance was controlled through the fracture thickness strain of the beam at 10 degrees Celsius and 50 mm per minute loading. The detailed fracture strain requirement can be referred to the asphalt pavement design specification. For control the rutting resistance of asphalt mixture, the minimum dynamic stability of asphalt mixture for expressway and class 1 highway should be determined based on the local climatic conditions. Meanwhile, the penetration strength of asphalt mixture should also be controlled. To ensure water stability, residual immersion marshal stability and the residual strength ratio of freeze-thaw split test should meet the corresponding requirements. For asphalt surface sneer, dynamic modulus should be tested at 20 degrees Celsius and 10 Hz, and 20 degrees Celsius and 5 Hz for asphalt base sneer. It should be noted here, sine wave type load was applied as compared with the half sine load applied in the resistant modulus test. That's all for today's lecture. I'll see you guys next time.